to electrical circuit. But first, before discussing the past paper question, a quick revision. Example, if we have a DC circuit means the source which supply the current can flow only in one way. We call it as a DC circuit. A DC circuit, it can be a series, it can be a parallel, or it can be a combination of series and parallel. So example, we have a 16-volt supply which is connected to two resistors, 6 ohm and 4 ohm, which are in series. So as they're connected in series, which quantity will be same for both resistors? Voltage or current as they're connected in series? Which quantity will be same for both? So the current will be same. They will have the same current. So what current flowed through 6 ohm, that will be same as the current which will flow through 4 ohm. Now, how we can solve this type of a question? So when resistor or other components are connected in series, the current at every point will be same. So example, if I say the current which is coming from the battery, that is 1.6 ampere. So how much will flow through 6 ohm? That is 1.6. And how much will flow through 4 ohm? And that is also 1.6. And how I can find the total current? If we want to find the current, we have the formula voltage V is equals to IR. If you are using the total voltage, then we need a total resistance. So what is the total voltage of the circuit? The total voltage of the circuit is 16. The current we don't know. And what about the total resistance? Because 6 ohm and 4 ohm are connected in series. So if two resistors are connected in series, what will be the combined resistance? If two or more are connected in series, how to find a combined resistance or the total resistance? So if you want to find the combined resistance, you will simply add the two resistance. So the combined resistance 6 ohm and 4 ohm as they are in series. So that will be equal to 6 plus 4, which is equals to 10. So 16 is equals to current multiplied by 10. If it is, we need a current. If it is multiplied by 10, other side it will be divided. So it will be 16 divided by 10. That is equals to 1.6 ampere. So this is how we work out the total current in the circuit. And the total current in the circuit, the total current is same, the total current which is coming out from the battery. So if 1.6 ampere is there, which is flowing out from the battery, same amount of current will flow through ammeter, same amount of current will flow through 6 ohm, and same amount of current will flow through 4 ohm, and the same amount will return. So the total current enter the circuit is always same as total current leave the circuit. If we have a series circuit, so all the components within the series circuit receive the same amount of current. But what about the voltage? In series, the voltage divide. So current is same. That's why if total current was 1.6, through each resistor, 1.6 ampere is passing. But if we need voltage, so basically in series, the voltage will divide. If the total voltage is 16, this total voltage is 16, some voltage will divide across 6 ohm resistor and remaining voltage will be there across 4 ohm resistor. How we can work out what is the voltage across each resistor? So as we know the current is 1.6, again we will use the formula V is equals to IR. But this time I'm finding the voltage across the 6 ohm resistor. So V is the voltage which I'm finding, I is the current, that is 1.6, multiply by the resistance. that is equals to 6. So 1.6 multiplied by 6, that is equals to 9.6. So if the total voltage is 16 and 9.6 voltage is dropped across the 6 ohm resistor, then the remaining voltage will drop across 4 ohm because the total voltage is equals to the sum of voltage divided or drop across each component. So 9.6 plus 6.4, the final will get 16 volts. Is it clear? So basically in series, the current is same and the voltage divide between the components. Any doubt in this? This is when the two components, two resistors are connected in series. But if two or more resistors are connected in parallel, like example, we have 18 volt supply, which is connected to 8 ohm and 2 ohm resistor, which are in parallel. So in parallel, which quantity is same? So if they are in parallel, what will be same, voltage or current? So the voltage will be same across each component and the current will divide in parallel circuit. So if we have a 18 volt supply, because only two resistors are there and both resistors are in parallel to each other, so voltage across 8 ohm will be 18 volts and voltage across 2 ohm is also 18 volt. And even if there is another resistor, like there was a third resistor which is also connected, and it can have any value, like even it is 100 ohm resistor. So what will be the voltage? That will also receive 18 volts. So in parallel, the voltage is same, but the current will divide between the components. So when resistor or other components are connected in parallel, the potential at every point in the circuit is same, means the voltage is same at every point. So if we have a 18 volt supply, all components will receive same 18 volts. But what about the current? The current will divide. And how to work out the current? As we know, the voltage is 18 and the resistance is 8. So we will use the formula V is equals to IR. If we need a current, current is voltage divided by resistance. So voltage is 18 and the resistance is 8. So 18 divided by 8, that is 2.25 ampere. And if we are finding for 2 ohm resistor, the current in 2 ohm resistor, the voltage is again 18 and the resistance is 2. So V is equals to IR, or I is equals to V divided by R. Voltage is 18 and the current is 2. So 18 divided by 2, we will get 9. So series circuits, they have same current and voltage divide. Parallel circuit, they have same voltage, but the current divide. But we may have a circuit which is a combination of both series and parallel. So if we have a series circuit, the current will be same across each. And the voltage will divide between the component. If we have parallel circuits, a complete parallel circuit, the current, the voltage will be same, where the current will divide between the components. But we may have a circuit which is a combination of series and parallel. So if it's a combination of series and parallel, means some places, some parts, the voltage will be same if they are parallel, and some parts the current will be same if they are in series. Example, if I draw a circuit in which two resistors are in parallel and two resistors in the combination are in series and they are all connected to each other. So this is a circuit with a supply. Example, if I say this is a 20-volt supply, so total voltage or EMF, basically it's 20. And these are resistors. So what happened when the current, if I say the current, which is the total current which is coming out from the battery, that is 4 amperes. So if the total current is 4 ampere, when it entered this parallel part, if these two resistors are identical, then this total 4 ampere current is a movement or the flow of the charges. So this total 4 ampere current will divide into or equal distribution. Why? Because I mentioned both are identical. If they are not identical, then it will have unequal division. But if they are identical, then equal division, like divided by 2. So if the total current is 4 ampere, when it enters the parallel branch, the parallel circuit, the current will divide. But when it passes through, it will rejoin again. So what will be the current here? 4 ampere. And that same current will passes through the two resistors which are in series, and same amount of current will return. So the current actually divide in the branches, and then if it's in series, it will remain same. This is what happened to current. But what about the voltage? Because we are saying the total voltage is 20. So if the total voltage is 20, it means that the sum of the voltages across the components, that should be 20. But in parallel, the voltage is always same. So if I say 6 volts was here, 10 volts was here. So out of 20, if 6 volts drop across one resistor and 10 volts drop across another resistance, so how much we are left? We are left with only 4 volts. So what happened to that 4 volt? That 4 volt will drop across the parallel combination, but because they are in parallel, if I say R1 was having 4 volts, R2 will also have 4 volts. So in parallel, even if there is another component, that will also receive the same voltage what is there across the parallel combination. Is it clear? So voltage basically voltage is same in parallel and divided in series, where current is same in series and divided in parallel. Now some questions we will solve related to this electricity. And before solving the question, just one more formula which is relating the electrical power or power. Power, the definition of the power, it is work done per unit time. Or another definition, it is rate of energy transfer. So how much energy change there per unit time or work done per unit time, we call that as power. So in electricity, so in terms of power, if we want to write a formula, power is equals to energy divided by time. That's the formula for power. But in electricity, the common terms which we use resistance, voltage, current. These are the terms which we normally use in electricity. But this formula does not include any of that term. So how we can rearrange this formula? So as we know, the power is equals to energy divided by time. Now, what is the formula for voltage? Voltage is also energy divided by charge. So voltage is energy divided by charge. So voltage into charge is equals to energy. Because charge, the Q is divided, other side it will be multiplied. So voltage into charge equals to energy. So in place of energy, I can write voltage multiplied by charge. So VQ divided by T. And what is the formula for current? The current is charge divided by time. So this Q divided by T, what I can do? I can replace this by current or I. So I can say the power is the product of voltage and current, or P is equals to V multiplied by I. So in electricity, normally voltage and current are given. That's why we use this formula. Other formula is also correct, which is power is energy divided by time. But normally in electrical circuit, you don't have energy. Normally voltage, current, or resistance are given. So you can use these values and find the power. Look, the formula, you don't have to learn the derivation. The final formula is important. The power means it is work done per unit time, or it is energy transfer or energy change in a unit time. So formula for power, P is equals to energy divided by time. Now, as we know, voltage is energy divided by charge. So charge is equal, energy is equals to voltage multiplied by charge. So in place of energy, I can write voltage multiplied by charge. And we know current is charge divided by time. So charge divided by time, Q divided by T, that is equals to current, or we can substitute with I. So the formula which can be used to calculate the power of any device or electrical component, we can multiply the voltage with the current to get the power. And the SI unit is watts. You can mention with capital W, or joules per second. So the final formula is important for electrical power. Okay, we will solve questions just to improve your understanding of the circuit. Figure 9.1 shows a 12-volt battery which is connected in a circuit containing resistor A, B, C, and D. Each resistor has a resistance of 6 ohm. So all are identical resistors and all have a resistance of 6 ohm. Means this one is 6, this one is also 6, and this is also 6 ohm. Now in the question, calculate the combined resistance of A and B. A and B, how they are connected, series or parallel? How A and B are connected? So A and B are connected in series. So if they are connected in series, so to get the combined resistance or total resistance, we will simply add. So 6 plus 6, that is equals to 12 ohm. For a 1 mark question, like if you find a question of 1 mark, so direct answer is acceptable. You don't have to show any formula or working. If you write the direct answer, that is correct. Or if you want to show your working, if you write 6 plus 6 here, or the total resistance will be R1 plus R2, that is also correct. But the marks, because it is only 1 mark, so that is only for the answer, not for writing a formula. combined resistance of A, B, and C. So what is the combined resistance of A, B, and C? A is 6, B is 6, and C is also 6. First, when we find the combined resistance of A and B, so the combined resistance or the total resistance of A and B is 12. So the total resistance of A and B is equals to 12. And the resistance of C is 6. They are connected in parallel. When two or more components are connected in parallel and we want to find the combined resistance, so the formula to calculate the combined resistance is the product divided by sum. Means multiply them. So it will be product. What will be a product? It will be 12 multiplied by 6 divided by 12 plus 6. So 12 multiplied by 6, it's 72. Product divided by sum, 12 plus 6 is 18. So 72 divided by 18, that is equals to 4 ohms. Is it clear? The second part. So the first one was 12, the answer. The second one is 4 ohms. Then we need a combined resistance of A, B, C, and D. So if we need a combined resistance of A, B, C, and D, we already worked out the resistance of A, B, C. So what is the resistance of A, B, and C? So that is 4. The total resistance of A, B, C is equals to 4. And the resistance of D is 6. So this one is 4 ohms. This one is 6. So what will be the combined resistance? So 4 plus 6, that is equals to 10. Is it clear, these parts? So why for AB, the answer was 12 ohms. For ABC, the answer was 4 ohms. And for A, B, C, and D, the answer was 10 ohms. Is it clear discussion? The combined resistance of the circuit. If you want to calculate for part B, when two or more resistors are in parallel, the formula for calculating a parallel, the combined resistance of the parallel, it is a product of the two resistance divided by sum of the two resistance. That's a formula for parallel. Because A and B collectively, as we work out, both are 6 ohm resistors. So the total resistance of A and B is equals to 6 plus 6, that is equals to 12. So for A and B, this like now this is replaced by A and B, which is total having a 12. So this one is 12 and this C is equals to 6. So when two resistors are in parallel, the formula is product of the two resistance divided by sum. So that is why it is 12 multiplied by 6, the product divided by sum, which is 12 plus 6. So 72 divided by 18. Next, calculate the current in the battery. If you want a current in the battery, means we need a total current. So if we need a total current, we have the formula V is equals to IR. V is the total voltage. The total voltage is 12. I is the total current which is coming out from the battery. And R, because we are finding for total, so we should take a total resistance. What is the total resistance of A, B, C, and D? The total as 1. when we work out the combined resistance of the whole circuit. So total resistance is equals to 10 ohms. So basically A, B, C and D are equivalent to 10 ohm resistor. That's why we say, so when we are finding a total current, we should substitute the total resistance. So this is 12, current I is there, and the total resistance of the circuit is 10. If it is multiplied by 10, other side it will divide. So it will be 12 divided by 10. What is 12 divided by 10? That's equal to 1.2 amperes. So 1.2 ampere is the total current which is coming out from the, yeah, that's right. So I is equals to V over R. You can substitute or rearrange the formula. So the total current is 1.2 ampere. Then energy transfer from the battery to the circuit in 50 seconds. Look, how to get the energy? We have the formula power is equals to energy divided by time. So if I need energy, that will be equal to power multiplied by time. So energy is equals to power multiplied by time. Now, how I can find the power? As we know, the last point we discussed, that the power is a product of voltage and current. Voltage multiplied by current will get the power. So what I can do, if I need energy here, energy is a product of power and time. And what is power? Power is equals to VI. So I can say energy is equals to VIT, where V is the voltage, the total voltage, I is the total current, and T is the time. So what is the total voltage of this supply? That is 12. Total current was 1.2, and time should always be in second. So when I multiply these, total voltage was 12, total current is 1.2, and total time interval is 50. Multiply all of them, you will get energy in joules. That is equals to 720 joules. So in an electrical circuit, what are the energy changes here? First, a battery will have a chemical energy. Inside the battery, we have chemical energy. This is not the question. This is just an information. A battery is having a chemical energy. When the charges start to flow, it will have electrical. But when the charges flow through the resistor, it will convert into heat energy. So energy change here, chemical change to electrical, and electrical changes to heat energy. Because here we don't have a lamp. If there was a lamp, then we will say light and heat energy. But we have only resistors are there. So resistor, when the charges passes through them, they produce heat. So that was the last part for the question. Another question. Question 7a. State in terms of the structure why metals are good conductor of electricity. What is the reason why metals are good conductor of electricity? Because they have free electron or delocalized electron. That's why they can conduct electricity well. So due to the presence of free electron, they can conduct electricity. The next question, a cylindrical wire W1 of length L and cross-sectional area A has a resistance of 16 ohm. A second cylindrical wire W2 of length L by 2 and cross-sectional area 2A, determine the resistance. So how we can determine if they are made up of same material? I told the formula which we will use if two wires, two materials, means two wires basically are made up of same material. So R1 A1 over L1 equals to R2 A2 over L2. So R1 is the first resistance. What is the first resistance? That is 16. So R1 is equals to 16. A1, the area of the first one is given A. So 16 multiplied by A. Length of the first one is L. So I will write L. Letter L. Resistance of the second wire, we don't know. Area of the second wire is 2A. And the length is L by 2. L by 2, I can write 0.5 L. That's the same thing. Because L by 2 having a same meaning as 0.5. Now, if I simplify, first I will cancel out the common factors. So A is common both sides. So A can cancel with A. L can cancel with L. So I will say what I'm left with 16 is equals to R multiplied by 2. Basically R2 multiplied by 2 divided by 0.5. But we want the resistance of the second resistor, which we call W2. So 0.5 is divided, other side it will be multiplied, and 2 is multiplied, other side it will divide. So 16 multiplied by 0.5 divided by 2. So 16 multiplied by 0.5, that is 8, and 8 divided by 2, that is equals to 4 ohms. So the final R2 is equals to 4 ohms. Is it clear? Yes, part. So whenever you are comparing the two wires made up of same material, then R1 A1 over L1 equal R2 A2 over L2. So this is the common question you will find when you're comparing the two resistors. Like if I say I have two wires which are made up of same material. This wire is having area A and length L. The other wire is having area A by 2, but it is a bit longer, length 2L. If this was having a 20 ohm resistance, what will be the resistance of the second one? If they are made up of same material, then when two wires are made up of same material, then the formula which we will use to compare the resistance of the two wires, that is R1 A1 over L1 equals R2 A2 over L2. R1 is the first resistance, which is 20. A1 is the first area of the wire, that is A. It can be any number or it can be a variable, like letter A is used here. And length of the first wire is L. We don't know the resistance of the second wire. The area of the second wire is A by 2. A by 2 means 0.5A. Because if something is divided by 2, it means it's half. So instead of writing A by 2, I can write as a numerator 0.5A. And length is 2L. So now what we'll do, first we'll cancel out the common factors. So area will cancel with area, length will cancel with length. So what we are left with 20 is equals to R2 into 0.5 divided by 2. This 2 is divided, other side it will be multiplied, and 0.5 is multiplied, other side it will be divided. So R20 multiplied by 2, that's 40, and 40 divided by 0.5, that is equals to, this is 20. 20 multiplied by 2, that's 40. And then 40 divided by half, that is equals to 80 ohms. So this is how we can work out the resistance of unknown resistor if we know the length and area. So in this question, the answer for this part was 4 ohms. Now, the effective resistance of W1 and W2 when they are connected in parallel. What is the resistance of W1? That's 16. And what is the resistance of W2? We work out, that is 4. What is the effective or the combined resistance when they are connected in parallel? So if two or more resistors are connected in parallel, the combined or the effective resistance equal to the product of the two resistance divided by the sum. So the product, that will be 16 multiplied by 4 divided by 16 plus 4. So 16 multiplied by 4, that is equals to 64, and 64 divided by 20. So when we solve this, the second part, that will come out 3.2 ohms. Is it clear, the second part? Because they mentioned that W1 and W2 are the wires and they are connected in parallel. So when the two wires are connected in parallel, or two resistors connected in parallel, or even two lamps connected in parallel, in which one of them is having, example, a 16 ohm, another one is having a 4 ohm. So we need a combined resistance. So the formula to find the combined resistance, it is a product divided by the sum. Is it clear, this part? B2. The parallel pair of resistors are connected to a battery that is made up of 3 cells, and each with a EMF or the voltage E. So if 3 cells are there, each is having a voltage of E, like 3 cells, each of voltage EMF E. This one is E, E, and E. So what is the total voltage produced by this combination? The total voltage produced by this combination when cells are connected in series. So if I say this is 2 volt, this is 2 and 2, so total voltage will be 6. But if this one is E, E, and E, so the total voltage will be 3 E. I'll continue explanation of this question in the next session.